Dear students, in the series of numericals, we are here with another numerical which is based on the average speed. Now we'll go through the questions. Now, why we are having sessions on the numericals? Because numerical is a very important part of physics. Now once if we clear that part with the help of numericals, then we can do better in physics. So for in any competitive examination, there will be questions which will be in the form of MCQs. So we are trying to solve these numericals in such a manner that there may be in the form of MCQs also. Now, if we go through this question here, an object is moving in a straight line, covers half the distance with a speed of 6 meters per second. Thus, half the distance covered in two equal interval of time with a speed of 7.5 meters per second and 9.5 meters per second respectively. The average speed of the particle during this motion is. Now, options are given to us. Now, if we go through a question which is based on the speed, now basically what happens? Many times the average speed, if you want to go to calculate the average speed, sometimes students do mistakes. What type of mistakes they do? They just take these values and add that. And suppose here we are having 3 speeds. So what they will do? 6 plus 7.5 plus 9.5. Add them, divide it by 3, and finally they will write the answer. But this is not the way. Now if we must need to know the definition of average speed. Average speed, if we go through the average speed is the total distance covered and total time taken by the object. Total time taken by the object. Now if we go through this question, so we are assuming a point A and here we are assuming a point C and we are joining them. Now here we have assumed this distance is x. X is the total distance that have to be covered by the particle or object. Now half of the distance, so this is x by 2. We are taking it as this point as a b. Now for x by 2, it has covered with a speed of 6 meters per second. So if we take the time to cover this distance, so time taken, because what we need to know the total distance. Here we have assumed total distance is x, and if we calculate the total time to cover this and total time to cover this, okay, so time taken will be given by, we are assuming it as a t1 for from A to B. Speed is given to us, that is speed is given to us 6 meters per second. So time will be given by distance upon speed. Distance upon speed. Now distance is here, it is x by 2 and speed is here given to us 6 meters per second. So time t1 which we are getting here, it is x upon 12 seconds. This is the time we have got for from A to B. Now here from B to C, in this numerical, in this question, a speed of 7.5 meters is covered by half of the, with equal intervals, half of the distance. The other half the distance covered into equal interval of time. So we can take T2 here, from here to here, and from another T2 it will here to here. So this, say we call it as a D. For B to D time taken, that is T2, and same interval D to C time taken as also T2. Now if we go through the distance covered from B to D, means we have taken the BD distance will be given by time into speed. Now here time, that is BD, distance, time is T2. Okay. Now how about the time? And that time we don't, that distance we don't know, but we know only equal interval of time. This from B to D it has taken T2, and from D to C it is also taken T2. So T2 into speed we have taken, that is 7.5 meter per second. So we are assuming this distance as a BD. So T2 will be given by BD upon 7.5. Similarly, we can calculate from D to C distance. So I am writing it directly now here. DC from D to C. DC will be given by again T2 into 9.5 meter per second. Now if we go through this, now here we are having this BD, which is T2 into 7.5, and if we add them these two, so BD plus DC will be 9.5, 7.5 T2 plus 9.5 T2. So ultimately we have 17 T2, and this BD plus DC means this distance, and we have taken this, half of the distance is covered, means the remaining from B to C, it is equal to B to C. So we have got B to C, that is x by 2, which is equal to 17 into T2. So T2 will be given by, that we can say T2 will be given by x upon 34. Now we have got this T2 and we have got this T1. Means if we need to know about the total times, so this will be the addition of these two. So total distance, that is x. Average speed, we want to know the average speed. Average speed, which is x, the total distance, and total time, that we can take T1 plus 2 times T2. Because it has taken T2 plus T2, it will be 2 times T2, and this is T1. The time taken here it is T1. Okay. So if we substitute the values, x upon, this is T1. T1 is your x by 12 plus 2 times T2 is x upon 34. So it is 17. So x upon, x is common, we are 1 upon 12 plus 1 upon 17. So here x to x cancel, and this 17 plus 12, it will be 29, and 12 into 17. Why 12 into 17? We have taken the LCM of these two, 12 and 17, and this. So it is now 1. So average speed, which is coming to us, it is 204 divided by 29. So it will be 7.03 meter per second. This is the average speed which we are getting in this case. So the C is the correct answer. Now a simple question. If you go through average speed, and in average speed, that is total distance covered by an object and total time taken to it. Now here the time is divided into 3 parts. One is T1 and another T2, equal interval of time, and distance is in 2 parts. So average speed, which we always calculate in this way. So don't do the mistakes and go accordingly. So this way we can solve the numerical, which is based on the average speed. Okay.